First question. A tall cylinder is filled with viscous oil. A round pebble is dropped from the top with zero initial velocity. From the plot shown in the figure in options, indicate the one that represents the velocity of the pebble as a function of time t. Now we know in fluids, when the pebble is dropped from the top of a tall cylinder filled with viscous oil, a variable force called viscous force will act, which increases with increase in speed. And at equilibrium, this velocity becomes constant. That constant velocity is called terminal velocity. When the pebble is falling through the viscous oil, the viscous force is F is equals to 6 pi eta r v, where r is the radius of the pebble, v is the instantaneous speed, eta is the coefficient of viscosity. As the force is variable, hence acceleration is also variable. So v by t graph will not be a straight line, and thus the correct answer is option C. Looking towards the next question. Along a streamline. Okay, so as discussed, that we know that a streamline flow of a liquid velocity of each particle at a particular distance or a cross section is constant, because we know that AV is equals to constant according to law of community between two cross section of a tube of flow. So we can say that along a streamline, the viscosity of every fluid particle while crossing a given position is the same. So correct answer for this question is option B, that the velocity of all the fluid particles crossing a given position is constant. Looking towards the next question. An ideal flow through a pipe of circular cross section made of two sections with a diameter 2.5 cm and 3.75 cm. The ratio of the velocities in two pipes is. So the situation is like D1, suppose this is a pipe where this is the one diameter and this is another diameter. Okay, now we have a formula that A1 V1 is equals to A2 V2, and suppose this is the area A1 and the volume travels from here is V1, and suppose this area is A2 and the volume travels from this is V2. Okay, so we have this formula according to equation of continuity. We know that nu1 or V1 upon V2 is equals to A2 upon A1. I can write A as pi d2 square upon 4 the whole upon pi d1 square upon 4. So simply from this I can write that nu1 upon nu2 is equals to d2 upon d1 the whole square. If we substitute the value of d as given in the question, that is 3.75 upon 2.5 the whole square, it gives out to be 9 upon 4. So correct answer for this question is 9:4, option A. Moving towards the next question. Which of the following diagrams does not represent a streamline flow? So streamline flow of a liquid is that flow in which each element of the liquid passing through a point travels along the same path and with the same velocity as the preceding element passes through that point. A streamline may be defined as the path straight or curved, the tangent to which at any point gives the direction of the flow of liquid at that point. The two streamlines cannot cross each other, and the greater is the crowding of streamlines at a place, the greater is the viscosity of liquid particles at that place. If we consider a cross-sectional area, then a point on the area cannot have different velocities at the same time. So the streamline this is not a streamline flow. Rest all are correct. So correct answer for this question is option D, and this is the diagram which does not represent a streamline flow. Looking towards the next question, the angle of contact at the interface of water glass is 0 degree, ethyl alcohol glass is 0 degree, and mercury glass is 140, and the mercury iodide is 30. So a glass capillary is put in a trough containing one of these four liquids. It is observed that the meniscus is convex. The liquid in the trough is. So according to this question, the observed meniscus of liquid in a capillary tube is of convex upward, which is only possible when angle of contact is obtuse. It is so when one end of the glass capillary tube is immersed in a trough of mercury, hence the combination will be of mercury glass 140 degree. So the correct answer is option C, that is mercury.